right, geometry people, hope you're doing okay this morning. I was thinking about your assignments and this worksheet in particular. I said, you know what, I'm just going to try this video thing. I want to see how it works. So I'm going to take you through a few things on this worksheet, this 11-2 worksheet, solving quadrilaterals practice. And maybe to do us both some good. So let's get up here to draw. Let's change the color. All right, let's start with, let's just go blue. Okay, so with the quadrilaterals, you're going to need to know a lot of properties. You need to be familiar with those. So hopefully in the prior days, you made a good graphic organizer that you can look at. There's plenty of stuff online as well, but you just need to know in the family tree of quadrilaterals, there are a lot of properties, okay, that you need to know. So here, this is going to be a couple of good examples right here, and let's just go through this. Now, this is very vague. They're going to give you some links. They're going to give you an angle measure, but the one thing I don't see here is what kind of quadrilateral they're referring to. So, you know what? I'm going to assume they want this to be a parallelogram, even though they really didn't give you a whole lot of information about this. But I'm going to go ahead and tell you, whoops, hey. I need to go ahead and say, hey, I'm going to declare this a parallelogram because you need to know that before you start running through this problem. Okay, are we on? Yeah. So this is a parallelogram. Okay, so I'm going to go ahead and say, hey, this is going to be a parallelogram down here. You know, the evidence, it looks like a rectangle, but you know what? You really don't have a whole lot else other than opposite sides are parallel. And if that's all you know, then technically this should be a parallelogram again. So, but the way they're going at this, they want you to go ahead and assume this is a rectangle. All right, even though I'm going to go ahead and tell you, disclaimer, they should be giving you more information. All right, but go ahead and assume the first one's a parallelogram, assume the second one's a rectangle. All right, let's do this. Now, let's go ahead and label. You need to label all your information. So DE, this top side is going to be 74. DG, now be careful, that's a diagonal, part of a diagonal, so those are a little different, so we got to be careful with those. So that's going to be 31. FCD, the angle, so F to C to D, that angle is going to be 42 degrees. Squeeze that in there. All right, so 42 degrees. So go ahead and put in all your information. Help yourself with these. All right, so here we go. Looking for CF. So CF is going to be down here. Now, first big property with parallelograms is opposite sides. Opposite sides will always be parallel, and they will always be congruent. So that's a big one that's going to help us out here. So if this is a parallelogram, that means 74 and CF, since those are opposite sides, they should be the same. They should be congruent. So that means this one's going to be 74. So, all right, that wasn't too bad. So opposite sides in a parallelogram should be parallel, which means they should be going the same direction, but they should also be congruent. They'll be the same length. So 74, 74. All right, moving on. Let's change color. Let's go red. All right, so next one. Find a measure EFC. So E to F to C is going to be this angle right here. All right, so now here's what you need to know about the angles in a parallelogram. All right, here we go. Couple things. I'm gonna split this up, two parts. Angles. First thing you need to know is if you talk about the opposite angles, Opposite angles will be congruent, which means they should always be the same. Okay, so if you're looking at angle D, angle F, those two would be the same. They'd be congruent. Angle C, angle E, those two should be congruent. All right, but it's not opposite angles they're asking for here. They're asking for the angles that are right beside each other, and we're going to call those adjacent angles. Now, adjacent angles, these are always going to be supplementary. Now, again, if you're talking about a parallelogram. So that's going to help us out right here because C and F, they're right beside each other. So those are going to be adjacent angles, which means they should be supplementary. So what you're going to do for EFC is you're going to take, hey, supplementary means 180 minus the other angle, so 42 is going to equal to, see here, so 180 minus 40 would be 140. Take another 2 off, that's going to be 138. Bam. There you go. So this angle right here is going to be 138 degrees. Okay? And just doing a quick review of the angles, opposite angles will be congruent. So if this is 138, it means angle D should be 138. If this angle is 42, that means angle E should be 42. And again, that means these two, if you're looking at D and E, since they're adjacent, they should be supplementary. E and F, if they're adjacent, they should be supplementary. So you see what's going on? A lot of details here with parallelograms. All right, change it up. Let's go to the last problem here, last part. Oh yeah, crazy. All right, so DF, where's DF? All right, now here's where things get a little stickier. DF is going to be diagonal. So as you look at the family tree of quadrilaterals, well, let me say that again. As you look at parallelograms, that family tree, from parallelograms up to rhombi, to rectangles, to squares, in each case, the diagonals are going to have a different property, but the basic property that goes along with all those parallelograms is that the diagonals should, let's see here, got this over here. Diagonals should bisect. At the very least, if it's a parallelogram. If it's a parallelogram, they should bisect. So which means that G should be the point, should be the midpoint right between D and F. That means that that length, which is 31, should be the same as this length over here. And if you want to put in a tick mark, you could. That little segment should be the same as this segment. As well as this segment should be the same as this segment. If this is a parallelogram, these will bisect, these diagonals will bisect, which means that point is going to be the midpoint for both diagonals. Now that helps us out here. So if we know this is 31, all we got to do is double it. This side's going to be 31. So we're going to come down here and say, hey, 31. We're going to double that length, and that's going to give us 62, which means that whole length from D to F should be 62. Okay? So, and again, going back to parallelograms, diagonals bisect. Now, as you move up to other shapes, like the rectangle, they will bisect and then they'll do something else. If you go to the rhombi, they'll bisect and they'll do something else. And similarly for the square. Okay, I think we did enough damage with that one problem. Let's try this other one. Now again, this bothers me a lot. This shape, all you know is they're giving you the tick marks for opposite sides of parallel, and by definition, that's a parallelogram. But to answer this question, you're going to want to assume that this is a rectangle, okay? Because if this is all they're giving you, you just don't have a lot to go on. So here we go. If it's a rectangle, that means rectangle by definition is going to be a parallelogram with 4 right angles. So write this down here. Parallelogram having 4 right angles. So to be a rectangle, first of all, you got to start off with parallelogram. And again, all this applies, but it's going to be a parallelogram having 4 right angles. So here's what you know. So if this angle is 5x minus 3 and it's supposed to be a right angle, so think about this, it means all these angles should be right angles, which means we know all these angles should be 90 degrees. So when you know things should be the same, what you should do is just come over here to the side, say 5x minus 3. We know it should be 90 degrees. So let's go ahead and it's going to be ugly colors here. 5x minus 3 and 90. We know they should be both the same. So we set them equal and start solving. Let's move the 3 over here. So we got x equals 93. Now this is not going to go well. Okay, you're going to get a decimal, but that's fine. So let's divide it up. So we'll divide both sides by 5. So x is going to go in what? 5. We're going at one time with 4 left over. That's 43. So we'll assume that's 8. It's 40 with 3 left over. It's 3 divided by 5. What can I think? 20, 40, 60 ish. So I don't have my calculator on me, but I think that's good. So that's it for this problem. That's all they want to know. So if you're looking for x, x is going to be 18.6. If you plug it back in, that should make a right angle. It should make 90 degrees. All right. I hope this was useful. Let me look at the bottom of the page and see if I want to go further.